All right, so we're going to do our Excel lab for the sampling distribution chapter, chapter 6. I'm happy to report this is going to be very short and sweet. So I say let's just do one of our examples from the lecture notes. So if we recall, we had a question where we were looking at the cost of unleaded fuel. So according to the AAA, the average cost of a gallon of regular unleaded fuel at gas stations in May 2014 was $3.65. Assume that the standard deviation of such cost is 15 cents. Suppose that a random sample of n equals 100 gas stations is selected from the population, and the cost per gallon of regular fuel is determined for each. Consider x bar the sample mean cost per gallon. Okay, so let's first just fill out our table. So our sample size, well, this was given to us, right? And here was given to us as 100. So the mean of the sampling distribution, so if you can read that, that's mu sub x bar. And we know it's just equal to the population mean, mu. And we were told that it is 365. And then we want the standard deviation of x bar. So the standard deviation of the sample mean, or we could call it the standard error, or we could say sigma sub x bar, which we know is equal to sigma divided by the square root of n. So let's go ahead and calculate that. So that's going to be equal. So our standard deviation is given to us as 0.15, so 0.15 divided by, I'm going to open a parenthesis just because I know that when we're dividing and using functions, it's always better to use more parentheses than fewer. So SQRT for square root of 100. So I'll just click on 100, close parenthesis for square root, close the parenthesis for the denominator, hit enter, and we get 0.015. So this is our standard error. Then if you recall, we had two questions. The first is, what's the probability that the sample has a mean fuel cost between 365 and 367? So I've rewritten that down here, so between 365 and 367. And then what is the probability that the sample mean has a mean fuel cost that exceeds 367? And I've written that in notation right here. So now we're just doing the same thing we did before on this tab. So we're just going to keep using the norm.dist function. So let's do equals norm.dist. So our x value, so recall we're going to need to subtract these two off. So we're going to have 3.67, comma, mean is 3.65, comma, standard deviation is 0.015, right? Not 0.15, but 0.015, because we're looking at x bar, not x, comma, true. And then we need to subtract, so norm.dist, 3.65, comma, mean, 3.65, comma, standard deviation, 0.015, comma, true, close parenthesis, enter. And we get something extremely similar to what we calculated in the lecture notes. Okay, x bar bigger than 3.67. Notice that because this is bigger than, we need to do 1 minus probability x bar less than 3.67. So let's do equals 1 minus norm.dist, so 3.67, comma, mean 3.65, comma, 0.015, our standard deviation, and then true, and we get 0.0912, something very similar to what we did in the lecture notes. And here's what I typed in. And that's all we're going to need to worry about for Chapter 6 Excel work.